All right, working on some inverse trig. So arc sine or arc cotangent, whatever. This is just another way of saying inverse. So the arc sine of sine x is just x. That's the identity function. Whenever you're compositive with your inverse. So notation, arc cosine is the same thing as cosine -1 of x. And remember, the basic concepts are if sine maps x to y, then arc sine maps y to x. This is how inverses work. So up here is basically your ranges, and this just makes sense that if you're working backwards, you've got so many choices on the unit circle that map to the same thing. They're just asking you to land your range. Three of them are between -pi/2 and pi, and that is sine and tangent and arc cosine, and the other three are from 0 to pi, and we might just have to look those up as we go. So let's take a look at what we're going to do with them. First of all, you've got to be solid on your unit circle, at least, the main things. I didn't even put in the pi/2s and the pi's and things. You got to be pretty good on the pi/3s, pi/4s, pi/6s, and the negatives, and even these ones over here that have a x value, which is negative, and a y value, which is positive. So we're going to start by solving some of these. So arc sine of -1/2 is what? So what this means is if arc sine -1/2 is question mark, that means that sine of question mark is -1/2. Again, remember that whole if it maps A to B, then the inverse maps B to A type thing. Don't forget, in this particular case, we went back and we understood that the sine domain, arc sine's domain, is between -pi/2 and pi/2. So what are we looking for? We're looking for the place where sine of some rotation is equal to -pi/2. Well, we know that sine of pi/6, remember, sine is the y value, sine of pi/6 is 1/2. So since this domain is -pi/2 to +/2, we just go down here to -pi/6, and that would be -1/2. So in this particular case, question mark is -pi/6. If we look at arc cosine 0 is equal to y, if and only if cosine 0 is equal to y, then again, we know that this happens up here at pi/2. Since the range is 0 to pi, we go ahead and just answer y equals pi/2. Arc tangents are a little more tricky, I guess, or if we work with arc cosecant or arc secants. So if arc tangent of rad 3 is equal to y, then tangent y is equal to rad 3. And what we kind of have to do is play around a little bit with the rad 3/2 and the 1/2. If rad 3/2 divided by 1/2, that's the same thing as rad 3/2 times 2/1. So the 2's cancel and we're just left with rad 3. So that means that y in this case is pi/3. If by some chance it's rad 3/3, that's the opposite. That's the part where you're talking about probably pi/6. All right, let's solve a couple more examples. What is the tangent of arc cosine of rad 2/2? Well, arc cosine of rad 2/2 is y, if and only if cosine y is rad 2/2. If we'll go back up here, we see that that is where the cosine is pi/4. So then we just have to look at the tangent of pi/4. Tangent of pi/4, since both of these are the same, is equal to 1. Another one would use right triangles to solve it. So they don't look like fractions that you're used to. So for example, arc sine of 5/13 is y, if and only if sine y is 5/13. You're like, I don't remember any of those 5 or 13. Use your right triangle trig, your whole S, C, and T, and opposite over hypotenuse, adjacent over hypotenuse. So you set it up. So if sine of this y is equal to opposite over hypotenuse, and if that's 5/13, then we can use Pythagoras to figure out this adjacent side is 12. If that's the case, if sine y is equal to 5/13 and cosine y is equal to adjacent over hypotenuse, or 12/13. So sometimes we have to use right triangle trig if we don't recognize the fraction. Derivatives. Derivatives are somewhat interesting. They basically all just come in forms. So arc sine of u, the derivative of that is u prime over 1 minus u squared. So if we used arc sine of x squared, then the derivative of that is 2x over rad 1 minus x to the fourth. And what I normally do is I write out what is u, what is du, and what is u squared out here to the side somewhere, and that kind of helps me get through those. Okay, so again, if derivative of arc secant of u is u prime over u times rad u squared minus 1, and they ask for the arc secant of 2x, then I write u is 2x, then du is 2, and u squared is 4x squared. Then I just go back up here and I say, well, this is where the 2 goes. This is where the 2x goes, and inside would be 4x squared minus 1. So I canceled out the 2, and we got 1 over x rad 4x squared minus 1. I kind of bounced all over the place with your homework, but here is the basic concepts of the numbers I want you to do. So again, the basic idea is please try a few of these and then come into class and let's make sure we can get finished up. But that is good enough for today. I'll wheel around to a couple of the last ones. We're going to do some derivatives at the end. All right, and we're going to have to remember chain rule and product rule and probably everything else like this, but here's the homework set.